Welcome to The Explainer. Today, we're basically cracking open a Stanford lecture on deep learning to give you a 10-minute roadmap for your career in AI. Let's get right into it.
Okay, so here's the game plan. We're going to start with why this is an absolute gold rush moment for AI. Then, we'll look under the hood at the deep learning engine that's powering all of this. After that, I'll lay out a learning map for you, talk about the skills you actually need in the real world, and cover the new rules of coding. And we'll wrap up with a big question for you.
All right, first up, the AI gold rush. And look, we're not just talking about some passing trend here. This is a massive, fundamental shift that's happening right now in tech and in the job market. I mean, think about it. At top universities like Stanford, a huge portion of all incoming students, from undergrads to PhDs, are all laser-focused on AI. You're not just getting into a new field, you're joining this global movement of some of the brightest people out there. The energy is just incredible.
And this isn't just some academic bubble. The industry is facing a massive talent shortage. Companies are practically begging for people who can build with this stuff, which creates this golden opportunity for anyone looking to jump in.
So, what's causing this explosion? What's the secret sauce? Well, it really all boils down to one single game-changing breakthrough. You know, for decades, AI progress was kind of slow and steady. It was interesting, but not revolutionary. Then, maybe 10 or 15 years ago, something just clicked. Performance didn't just get a little better, it went completely vertical. So, what on earth happened?
And this chart is the key. See, older AI models would just hit a wall. You could give them more data, but they wouldn't get any smarter. But deep learning models, these things called neural networks, are totally different. They have this superpower. The more data you feed them and the bigger you build them, the smarter they get. It's this amazing virtuous cycle.
So yeah, deep learning, that was the key. It gave us a recipe to build bigger and bigger models that could finally make sense of the mountains of data we were collecting. It unlocked this whole new era of scalable intelligence. And get this is the craziest part. This whole revolution didn't start in some billion-dollar corporate lab. It was kicked off by a Stanford undergrad, a guy named Ian Goodfellow, who was building a server in his dorm room. That just goes to show you how accessible this field can be. You don't need a huge budget to make a world-changing impact.
Okay, so you see the opportunity, you get the core concept. Now the big question is, how do you actually get started? Well, here's your map.
You can think of it like a stack. The foundation, the absolute base layer, is solid computer science fundamentals. You can't skip this. On top of that, you build your understanding of machine learning principles. Then you specialize in deep learning, which is the engine that drives that top layer, generative AI. You know, the tech behind tools like ChatGPT and Midjourney.
So why are those fundamentals so important?
Well, the professor uses this perfect analogy. Knowing the fundamentals is like knowing the language of art. It lets you command the AI with incredible precision and nuance. Without it, you're just stuck asking for pretty pictures of robots and wondering why your results are so meh.
All right, let's talk about what it's really like to work in this field. Because it's not all about theory and textbooks. It's about rolling up your sleeves and actually building things that work in the real world.
This really isn't a typical 9-to-5 job. It's more like a craft. The professor talks about being in the office at 2 or 3 in the morning, just tweaking things, fiddling with parameters, trying to get a model to cooperate. That hands-on dedication, that's often what separates a project that works from one that completely fails. So a great AI education gives you this incredibly practical toolkit. You'll learn how to build neural networks in Python, how to tune all the little knobs and dials, the hyperparameters, to get the best performance, and how to run a really disciplined project. You'll even get to specialize in models for images or for text, like the transformers that power all the big language models. Okay, now let's connect all these skills back to getting a job because, and this is super important, the rules of the game for software developers have fundamentally changed, forever. Imagine you're hiring for a role. You have two candidates. Candidate 1 has 10 years of solid experience, but they still code everything by hand the old-fashioned way. Candidate 2 is fresh out of college, but they're a wizard at using AI coding assistants as a partner to build things incredibly fast. Who do you hire?
Well, the professor says it's not even a question. He'd hire the new grad who's fluent with AI tools every single time. Because today, not using AI to help you code is like insisting on using a typewriter in an office full of computers. You're just putting yourself at a huge disadvantage.
See, with AI as your co-pilot, you can prototype and test maybe 20 different ideas in the time it used to take to build just one.
This lets you find what your users actually want, spot problems way earlier, and just build better products faster. It's about moving fast, but also being smart and responsible about it.
So, you've learned the fundamentals, you've mastered the tools, and you understand the new rules of the game. What now? What can you actually do with all this incredible power?
Well, you could be on the front lines of cybersecurity, building AI that detects and stops financial scams in real time, literally protecting people's life savings.
Or maybe you team up with climate scientists, using your AI skills to build better models of our planet's future, helping to tackle one of the biggest challenges humanity has ever faced.
Or you could dive into these huge industrial problems, like optimizing global shipping routes to save massive amounts of fuel, cut emissions, and make everything we buy a little bit cheaper and cleaner.
Look, as the professor says, these skills give you a bewildering right to play in almost any field you can possibly imagine. The demand for people like you is massive. The path forward is clear, and the tools are literally at your fingertips. So really, there's only one question left. What problem are you going to solve?